thanks to all the speakers today. It's really fascinating overview. I'm a mycologist, work on fungi, and hearing all about the algae is really, really interesting. We do have time for a few questions, and I know you've been answering some of the questions from the panel, which is great. And also worth mentioning that we have the recordings of this webinar. We will be making that available through the BioHUB website and also through various other routes, so you'll be able to look back on these. While we look at kind of some of the general comments, Alice, there was a specific question directed to you about your work and saying, is there any analysis for extracellular products for specific strains? Hello, can you hear it? We can't hear you.
Yeah, you better. Yeah, you just have to collect the media. Things like extracellular stuff, they can quite often be secondary metabolites, so you might want to do LCMS, but you get a lot of excreted carbohydrates as well, which might be extracellular polysaccharides, and that can be analyzed by HPAEC for sort of monomer analysis of the sugars to work out what's making up those polymers, which can be quite good too.
Thank you. We have some kind of remaining questions, and I know people have been answering them. There was some, particularly at the initial part of the presentations, questions about, well, what is the feasibility of algae to delivering towards a large-scale industry, particularly around biofuels and the likes. And I think both there was some reference to this by some of the presentations, where looking at maybe high-value parts of the algal biotechnology kind of area to make things a little bit more financially viable. I don't know, does somebody just want to quickly summarize that kind of view on algae and biofuels and where the actual potential is, you think? And somebody asked a question about bioremediation, and we know we take industrial waste, and there's certain companies that are looking to particularly capture CO2, for example, and that's a good route. But is there other examples of bioremediation that people might be thinking about as well? Yes, Steve?
Yeah, I can answer some of that. I mean, I think the thing with microalgae is the same as crop plants, is that they'll actually take about 5% of the light energy from the spectrum and assimilate that energy into biomass. If you've got to compare that with solar panels, which solar panels are really pushing much higher than that. So if you want direct conversion of sunlight into energy, it would be solar power. So with microalgae, you have to make a product that's valuable. And one thing you might notice with these petrol prices going up because of the Iran business is people start to ask questions like, can we put cooking oil into their diesel tank? And that's something that's happened before. When the oil price gets high enough, which gives you kind of impression, if cooking oil gets to the point where you can actually use it as fuel, then maybe algal biofuel could be viable if that's the situation you had. But I don't think the algal biofuel companies which are producing cooking oil, I don't think it's like the low-grade stuff, it's high specialty stuff, omega-3, high omega-3 and stuff like that. So the economics don't quite stack up to produce biofuel. And there's the question of scale as well, is that your sort of yields in these large-scale open ponds is around about 10 to 20 grams of carbon per square meter per day. So you do need an awful lot, as Matt also pointed out in his reply. You do need a large volume. So so the question is whether that is possible. It's you certainly need the land areas to do it. And as I said before, there may be a possibility of it, but the best way for this sort of energy for transport would be to go via the solar panels and electricity and so forth, the typical renewable systems that people are mostly investing in, whereas algae is best for natural products, but there's a strong case for using it for remediation as well. So the second point was remediation. So since about the 60s, people have attached various kind of microalgae ponds to try and process wastewater or sewage. So those sort of things have been going on experimentally for quite a long time. So there's groups, especially in New Zealand, as I mentioned, where they're trying to scale this up. So again, the thinking about this is to take existing sewage plants, treatment plants, and trying to sort of add algae onto the side of this, but this has its limitations. For example, in the UK, it's land area and also the business of what are your yields during winter. So in New Zealand, for example, their yields during the winter tend to be about 50% or slightly less than they are during the summer period. So you have that issue of reduced production during the winter period. But on the other hand, if you're looking at high value products, then for example, people have been growing microalgae in Iceland in photobioreactor tubes using the cheap electricity from geothermal plants and so forth. So so it depends what the context is. But again, there's high potential with waste water treatments, and but there's also issues of if you want to make high value products from that, then you've got to avoid the heavy metal contamination and also the contamination potentially with microbes. So.
People are asking about that as well. Thanks. These are very comprehensive. Does anybody else want to add anything to that? Were some additional questions relating to kind of the feasibility of the actual production, of whether how much light is required at the time, and just the actual building the kits, which I think a lot of the supply chains for producing the bioreactors is available, but then once it's operating, what's the requirements? I know you answered a lot of that already, Alla and Matt, but do you want to say anything more and expand that a bit more?
Yeah, thank you for the really interesting question. So it seems like, so the understanding is going. So with some questions, yeah. So most of our reactors and the reactors what we install is commercially available, but we also did some custom-made design specific for different location. And I think specifically for brewery, yeah, our brewery is located in a rural area, and so we got lots of land around. So in the brewery itself is like surrounded by a farm, whereas the land not a main problem. But I can imagine if brewery, for example, located in city or or something. So it could be it's needed to be I think specifically designed for the place available. For example, like Gao breweries gets less land already, so and we discuss how we could potentially put systems for the algal remediation work. So most of the system need light, so because we're focusing on autotrophic condition, and is different design of algal photobioreactor is now improving, and some of the design specifically for United Kingdom, so with natural light, sunlight access is limited, is developing different system with submersible light, but obviously it's like some validation is needed in terms of electricity, so covering and not with water, because it's not quite easy to produce. But we're working with different companies and also like researchers as well in Swansea University developed different design for the bioreactors as well.
Okay, thank you. And there was another number of questions about contamination and whether cultures are sterile and what the kind of impacts are and how do you clean between treatments. And so again, I know a lot of those questions are answered, but is there anything more to add at this point on that point? One came in as particularly how do you clean between batches as well?
I mean, I comment as well, but so I'm welcome from our panelists to answer this. So yeah, we use different reactors, so different size and different species as well. So between cycles, we using sodium hypochlorite, so for the cleaning as a chemical sterilization, because we use quite large volume of water. And like, for example, autoclaving or any other method is not possible for us. Thank you from the audience about hydrogen peroxide, so we probably should try this as well, so find this quite interesting. But yeah, so we're not using any other like cleaning and mechanical cleaning as well with the brush sometimes, depends on of the system, design of the system as well. But bear in mind, large scale is never axenic culture, so because it's just simply impossible, even if it's closed system, this system what we are using, so maybe some system for heterotrophic growth could be, so aseptic and like used for the axenic culture, but not in our case. Maybe some other panelists can add something to it.
Everyone has covered it very well, thank you. I know I'm getting so short on time. There was a couple more questions that came in we can maybe quickly look at. One is looking at when we're talking about the slow release fertilizers, whether there are carbon species that would allow soil carbon replenishment in addition to fertilization that's going on. And I know some of the work is linking blending algae in with other components like biochar and that kind of thing, which would help with that. Is there anything more we can say on that at the moment?
I can also comment on it, I think. So yeah, research on this application is still ongoing, so it's quite early stage to say something. The idea is there, so for slow release fertilizer and even like biostimulant components from algal biomass, but also different methods of pretreatment of the biomass before it's going for the formulation, and then formulation of different algal species raw biomass also investigated. So yeah, please follow us more, so with more other webinars and more research, so on this aspect.
Yeah, so a little bit is watch this space, I think, as it's developing. And then the final one is a kind of a question that's come in that somebody has referred to an algal tree, the equivalency of growing a tree to the carbon that's equivalently captured in algae. Something I don't know anything about. Can anybody comment on that? Then it's got some advice for the questioner.
Matt, yeah, I think the answer is it depends. It depends on what you're trying to do. I've seen these comparisons sort of bandied about quite regularly. So the oxygen production, the carbon uptake can sometimes be faster. Various species of algae compared to some trees, but depending on which tree you choose, what time of year. But you need to be mindful that trees obviously can sequester the carbon in more complex structures like lignin, which are a bit more recalcitrant, so they're harder to break down. So the amount of carbon you fix, if that's your ultimate goal, will potentially be higher in a tree because it can store it in carbon compounds that are harder to break down compared to something like algae, where the algae sludge goes into the environment and can break down much faster. So the amount of carbon that's locked up is potentially less in algae. But again, when you look at these life cycle analyses and these comparisons, it's you need to be very careful comparing like for like, and you can probably get whatever answer you want if you take to that comparison carefully. So yeah, be careful, I think, is the answer.
Yeah, that's great. Thank you. That's good. I think we're going to have to wrap up. I know there's other questions coming in. I don't think we use antibiotics in algal cultures, so trying to avoid widespread antibiotics use. As for wrapping up, Hans, did you want to say anything more? Obviously, you can contact us through the BioHUB email address, biohub@swansea.ac.uk. We will be making future events available and advertising them through the website and also through various channels. We do have email addresses as well, so we can circulate that as emails. Is there anything else that we need to consider at the moment, Hamza?
No, that's all of it. So we'll be sending out a feedback form to everyone. So if they'd like to give any feedback, you're more than welcome to.
That's great. Okay,
yeah, yeah, that's it. Yeah.
Do you want to say something about IPM?
Yes. Yeah, please.
Sorry, go on, Hamza. You've been organising.
No, Mike was mentioning about IPM. If you want to go, Dan.
Yeah, we do a whole range of meetings and events, and one of the main one in our calendar is IPM, a new IPM meeting, which is integrated pest management, but it has a broad remit and is encompassing a lot of what we do in the natural products.